Hey everybody, and welcome to Dividing Decimals Part 2. Long Division Strikes Back. I'm sorry that I'm still not with you guys. I miss you all, and I miss London, not least of all because right now, as I'm making this recording, it is negative 10 degrees Celsius outside, which is not warm. So, as I said, back with Dividing Decimals Part 2, Long Division Strikes Back. Long division is probably going to be the main way you want to divide most decimals because it's the most handy method to use when the answer isn't a whole number. Today we're just going to practice doing it with whole number answers. Then next week we'll finish up this kind of mini unit with answers that aren't whole numbers. So just a reminder of the two methods that we looked at in Dividing Decimals Part 1, which was using common denominators, writing out a fraction, writing out a decimal division as a fraction division with a common base 10 denominator, and then dividing just the numerator. So in this case of this problem of 7.8 divided by 0.13, we wrote it as 780 hundredths divided by 13 hundredths and just can do 780 divided by 13, which equals 60. So that was option 1, just rewriting the whole thing as a fraction division with common denominators. And option 2 was writing just one fraction with the decimals inside it, so 7.8 over 0.13, but then changing that to a fraction that did not have decimals in it. And so in this particular case, we would have had to multiply both the top and bottom by 100, and we would have gotten 780 over 13, which, oh, look, it's the same thing we had in the first strategy. So it's essentially two different formats for doing more or less the same thing. So for problems that kind of work out to nice happy whole numbers, and where the numerator tends to be bigger than the denominator, this is a perfectly good method. But like I said, we're going to need another method when we have numbers that don't work out to nice happy whole number answers, which let's face it is usually most problems. So just for that, we're going to have to move to long division, using long division for decimal division. So just a quick review of long division in general. I know we reviewed it earlier, but it never hurts to do it again because you just can never be too good at doing long division. So suppose two boys who live near a golf course search for lost golf balls because they're really bored. They collect 6,324 balls and package them for resale. Actually, I guess they're really smart and are trying to make some money. So how many packs of 12 golf balls can be made from a supply of 6,324 balls? So this is just like our lifesaver scenarios, but instead of lifesavers, you can have golf balls. And you can still think of it in the same way. You can imagine that they had 6 crates of golf balls, 3 boxes of golf balls, 2 rolls of golf balls, and 4 individual golf balls, just like the lifesavers. So if 6,324 golf balls are packed in 12 boxes, how many balls will be in each box? So what I want you to do right now is I want you to actually write out the number sentence that describes the situation. So that's the problem. What is the problem? And then I want you to solve it in your notebooks using the traditional long division algorithm. So please pause the video right now. Work that problem out as a long division using the traditional method that we worked on before break. And when you are done, you can go to the next slide to check your work. So pause now. Okay. So looking at this problem, 6,324 golf balls split into packages of 12. We want to know how many packages of 12 we can make. So we set it up as 6,324 divided by 12. So we're taking 6,324 objects. We're not dividing them into 12 groups. We kind of are and we kind of aren't. We're trying to see how many, if we put 12 golf balls in a group, how many groups are we going to make? So it's just the flip side of that, which is still using division. So 6,324 divided by 12. If we ask, if you think of having the 6 of that first digit, that's like having your 6 crates of lifesavers. We can't split 6 crates among 12 equal groups. So we have to change those crates in and take out, we have to open up those crates and take out the boxes that are in. And remember, there are 10 boxes in each crate. So then we got 63. So now we have 63 boxes you can think of lifesavers, but in this case, it's golf balls. And I can distribute 63 things to 12 groups. And I can give 5 things to each of the 12 groups. And so then I know that 5 times 12 is 60. And I would have, so I'm using up 60 boxes of lifesavers, or in this case, golf balls, as I distribute them. And I'm going to have 3 left over because 63 minus 60 is 3, right? I can't split those 3 up without changing them out for the rolls. So I would end up with 32 rolls now because I would have had 3 boxes. That would have turned into 30 rolls. I add the 2 that I already had. That would be 32 rolls, or in this case, 32 rolls of lifesavers, or in this case, golf balls. And I can split 32 things among 12 groups. And I can put 2 in each group, which would use up 24. I'd have 8 rolls left over. If I had the 8 rolls left over, I'd have to change them out for it because I can't split the 8 into 12 groups without changing them for individual lifesavers / golf balls, right? So that would give me 80 because there are 10 in each roll, and the 4 that I already had. So then I have 84. Those 84 things can get distributed evenly among the 12 groups. And I would get 7 in each group, which would give me 84 with none left over. So if I'm taking 6,324 things, and I'm putting 12 of each in a group, that's going to give me 527 groups. So hopefully you got 527 as an answer there. Moving on. So what does this all have to do? What happens when we actually are doing long division with decimals? Well, as you may have noticed, long division really only works when you don't have decimals in your dividend or your divisor. So let's look at this problem. Use what you know about the connection between decimals and common fractions to explain why the quotient of 15.6 divided by 3.12 is the same as 1,560 divided by 312. Okay, so take a minute, pause, write it in your notebook. Why are these 2 problems the same? Explain to me or show to me in your notebook how you know these 2 problems are the same problem. So pause now, and when you're ready, hit play again. Okay, so I'm just going to go back to what we were doing in method 2 for the first lesson, which is where we're going to write the division, the original division of 15.6 over 3.12 as a fraction instead of in our kind of long divisions format. And remember, when we did this, we had to get rid of the decimals. And we need to rewrite these both so that they are whole numbers. So, as we see, we can actually multiply both the top and the bottom by the same number. I'm just realizing as I do this that I actually multiplied and multiplied both top and the bottom by the wrong number. It should only need to be multiplied by 100, not 1,000. So that's my fault. I'm sorry. I got overexcited and just added extra zeros. So 15.6 and 3.12 can both be multiplied by 100 to remove the decimals from the problem. And then, if we did that, we would get 1,560 divided by 312. So technically, if you were multiplying by 1,000 like I said I was doing, it would be 15,600 divided by 3,120, which would also work. But just imagine that those last zeros aren't there on the 1,000 and we're just actually multiplying both top and bottom by 100. So we get 1,560 divided by 312, which you will notice is the same exact thing, right, as we have up in the problem. It's just written in the long division way up there instead of in the fraction way, but it's the exact same thing. So it's nothing different than method 2 that we were using before. We're just putting it in the long division format instead of a fraction format. And I put a little heart around it because I know how much you love long division. All right, so as I said, they're the same because we've multiplied both the numerator and the denominator by the same power of 10, creating the same problem written with different numbers. So because we've multiplied both the top and the bottom by the same number, regardless of whether it's 100 or 1,000, our problem looks different, but it doesn't actually change the core problem itself because the numbers stay what's called proportional. They're in the same ratio. So what I want you to do now, so for each of the following decimal divisions, you're going to write the division as a whole number division that will give the same result. So what we just did on the previous slide. Explain how you know that your new problem is equivalent to the original, right? Why? Because we're multiplying both top and bottom by the same power of 10. Then I want you to actually solve it using long division. And then, lucky you, you can actually check your answers by using a calculator to do the equivalent decimal division. So when you type it into your calculator, type it in with the actual decimals and see if you get the same answer that you did when you wrote them out as long division with whole numbers. Okay, that's always a good check. So please do all the steps and show your work in your notebook. This is part of your homework. So you can either pause it now or you can come back to it in a minute because there's one more slide that has a homework question on it that I wanted to go over. So you can either pause now or just listen to the next slide. Okay, so the last question that I want you to do for homework is suppose that you are given a division problem in the form of divisor and dividend, okay, in the long division format. So I want you to write out, describe, that means use words, people, describe a procedure you can use to rewrite the decimal division problem as an equivalent whole number division problem. So if you were given a long division problem that had decimals in it, explain to me in words how you could rewrite the problem so that it is an equivalent whole number division problem. So it only is a problem that has whole numbers. Okay, so the problems on the previous slide and this problem are what you need to do for homework, and you will check it in your next class. Okay, have fun, and I will see you soon.